Hello students, welcome to all. In the last class, we are already studying some basic concepts of motion and types of motion. In this class, we will classify the motion according to two categories. The first category of motion is called as uniform motion. What is meant by uniform motion? First, I read this definition. When object travels equal distances in equal intervals of time, the motion is called uniform motion. You can observe this one. Any object that travels equal distance. Here, the two words are very important. The first one is equal distances in equal intervals of time. These two words are very important to understand this uniform motion. Students, I will take one example. You can understand what is uniform motion. Here, I traveled a car from point A. So, through the point A, I traveled a car through the point B. It covers a distance 100 km in 1 hour. So, in 1 hour, the distance is 100 km. Next, I continue the journey here. I continue the journey from point B to C. Again, I cover 100 km in 1 hour. So, here the distance covering is 100 km in 1 hour. Similarly, next I will continue the journey from C to D. Here also, I travelled 100 km. The distance between C to D. The distance is 100 km. I cover this distance in 1 hour. Look at this one. Here, in first hour I travelled 100 km. Second hour I travelled 100 km. In third hour also I travelled 100 km. So, you can see this one. Here the distance is same. Equal distances. In equal intervals of time. So, 1 hour, second hour, third hour. So, in equal intervals of time, the object covers equal distances. That type of motion is called as uniform motion. So, this is what in our day-to-day life we can observe this type of motion. Similarly, we again understand what is non-uniform motion. So, I read this definition first. If an object travels unequal distances in equal intervals of time, here some difference is there for uniform and non-uniform. So here the object travels unequal distances. Unequal means not equal. In equal intervals of time. Students, you can see the example. Here also I travel a car from point A to B. I cover a distance 100 km in 1 hour. So I continue the journey from B to C. Again, I travelled 1 hour, but I cover a distance 80 km. Next, I continue the journey from C to D. I travelled 1 hour, but I cover a distance 60 km. You can observe this one here. The distance will be changes. So, unequal distances. 100 here. In first hour, I travel 100. Second hour, 80 km. In the third hour, it is 60 km. Means here the distance remains. The distance is not equal, but the time remains same. So, that is what non-uniform motion means. An object travels, otherwise covers unequal distances in equal intervals of time. That is called as non-uniform motion. Now, let us understand the very important quantity, that is what the speed. Students, here you can look at this example. Here I travel a car from point A to from point B. I will take 1 hour and I cover the distance 100 km in 1 hour. Here a person X should take 2 hours for covering this same distance. Y is another person. He takes 3 hours to cover this same distance. And Z is one more person. He takes 5 hours to cover this distance. Students, you can see this one. Here I will explain the term of speed. say y and z, y is faster than z because y takes less time to comparatively z. So what about the xy and z? You can, z is slower than xy. Okay. So here the speed will be changes. So in equal intervals of time, in different times, it covers same distance. So I cover 100 km in 1 hour. X should take 2 hours to cover this distance. Y should take 3 hours to cover the same distance. Z should take the 5 hours to cover this distance. So here the speed will be changes. So what is meant by speed? Speed is the distance travelled per unit time. Distance travelled per unit time. So the different persons take a different time to cover the same distance. That's what. So in mathematically we can say speed equal to distance travelled by time taken. So the SI unit of distance is meter. So that is what small m, and the SI unit of time is second. Therefore the SI unit of speed is meter per second. So, and one more thing, speed is a scalar quantity. So, what is meant by scalar quantity? It is having only the numerical value. Here, the direction is not comes, only the numerical value is also coming. That's why it is called as a scalar quantity. The SI unit of speed is meter per second. So, next I will go through the next concept, that is what? Uniform speed. What does this mean, uniform speed? So, I will read this definition. If an object travels equal distance in equal intervals of time, then speed would be uniform. So, here I will take one example. I cover a distance from point A to B. So I cover 100 km in 1 hour. So next I continue the journey from B to C. From B to C, the distance is 100 km in 1 hour. So an object covers equal distances. Observe this one. So A to B 100 km in 1 hour. Next B to C, the 100 km in 1 hour. So in first 1 hour, an object covers 100 km. The next 1 hour, the object covers 100 km. So that is what? An object travels equal distances in equal intervals of time, then the speed would be uniform. So here what happens? Speed is nothing but distance by time. So distance is 100, time is 1 hour. So that is what? 100. The speed of this from point A to B is what? 100 km per 1 hour. Similarly, the speed of from point B to C is what? 100 km per 1 hour. So here the speed will be constant. That is what? The constant speed is called as uniform speed. Similarly, I am going to the next very important concept, that is what? The non-uniform speed. So here unequal distances is travelled in equal intervals of time. Students, you can look at this one. Here I start the journey from A to B. I cover distance 60 km in 1 hour. Next I continue the journey from B to C. Then I cover the 50 km in 1 hour. So here the time remains same. Time will be same, but the distance will be changes. So any object covers unequal distances in equal intervals of time is said to be as non-uniform motion. Here what happens? In 1 hour the speed is 60 km. From A to B the speed is 60 km. From B to C the speed is what? 50 km. So that is what? The speed will be changes. That is called as variable speed. Okay. So the variable speed is nothing but non-uniform motion. So in our day-to-day life we can see this type of motion. So when a car is moving in a crowded road, so that is what? Non-uniform motion. Otherwise a person is jogging in a park, that is also a non-uniform motion. Now coming to the very important concept, that is what? Average speed. So in non-uniform motion we go through the average speed. So example. So what is average speed? Average speed is nothing but total distance travelled by total time taken. So here this is a non-uniform motion. So total distance is what? 60 kilometer plus 50 kilometer divided by 2 hours. This is first 1 hour, second hour, so 2 hours. So total distance is 60 plus 50. Total time is 2 hours. So 60 plus 50 is 110 by 2. That is what? 55 kilometer per hour. So students, so in any non-uniform motion we can calculate the average speed. Students, now I am going to talk about velocity of an object. Students, previously we discussed about speed of an object. Now consider an object. It moves with a speed 10 meter per second. So it can be written like this also, meter second minus 1. Here you consider the object. The object moves with a speed of 10 meter per second. So in a positive axis, that is positive x-axis. So you already learned speed is a scalar quantity. What is meant by scalar? Scalar is nothing but only the magnitude. There is no direction. Suppose I give the importance of direction of motion. For this moment, I give the more importance to direction of motion. We get a new quantity that is called as velocity. Velocity is nothing but speed of an object moving in a definite direction. So here an object moves in a 10 meter per second with a definite direction is called as velocity. Velocity is nothing but speed with direction. Velocity is called as vector quantity because it is both numerical value and also direction. That's why it is called as vector quantity. Velocity can have uniform, either it is in uniform or it is in variable. How can we explain the uniform velocity of an object? Suppose here I consider an example. Here a straight road is there. So this straight road connects our home and railway station. In this straight road, I want to go to the railway station. You can imagine that you can go in a car. Suppose our car moves in this direction along with this 50 kilometer per hour speed. The car moves in this point. The speed of that car is 50 kilometer per hour. Next moves in this direction. Then also the speed is 50 kilometer per hour. Next continue our journey. Here also the speed is 50 kilometer per hour. Here also the 50 kilometer per hour. Finally it reaches railway station. Then also the speed of that car is 50 kilometer per hour. So the speed of that car is 50 kilometer per hour. That is called as uniform. What about the direction? Here there is no obstacle in this direction. That's why the direction also no changes. That's why the direction also uniform. Here both speed and direction are constant. That type of motion is called as uniform velocity. So the object is in uniform velocity. So both speed and direction are uniform, or there is no change in speed and there is no change in the direction. That type of motion is called as the uniform motion. So the velocity or the object is in uniform velocity. Suppose now the car changes its speed 50 kilometer to 40 kilometer. So it decreases its speed. Again it rises its speed. That is what? 60 kilometer per hour. What happen here? Here the speed changes. The speed will non-uniform. So on the same time the speed is changes. That type of velocity is called as variable velocity. So here the speed changes in the definite direction. Then also the velocity is variable. Suppose the direction changes. In some cases, the direction also changes. That is what? The velocity is in variable. Suppose both speed and direction both are changes, then also the velocity is in variable. So in generally, the objects, the motion of an object are in variable velocity. Students, you are already learned the average speed in the last classes. Now I am going to talk about average velocity. There are two expressions for average velocity. The first expression is displacement divided by time taken. So displacement, you know that what is displacement in the previous class, and the time is also learned. So what is displacement? Displacement is nothing but the shortest distance between initial to final point is called as displacement. So what is the SI unit of displacement? The SI unit of displacement is meter and the time taken is second. That's why the average velocity of the SI unit is meter per second, and it can be written as meter second raised to -1. Here there are another expression, that is what average velocity is equal to initial velocity plus final velocity divided by 2. So students, you can see this one. What is initial velocity? It is the velocity of the object with the object moves initially, that is called as initial velocity. What is final velocity? It is the velocity of the object with the object moves finally, that is what? Final velocity. So divided by 2. So that is called as average velocity. The average velocity can be written like this also. VAV. AV means average, V means velocity. The average velocity is equal to initial velocity can be denoted by letter U and final velocity can be denoted by V. So divided by 2. So it is nothing but the arithmetic mean of initial velocity and final velocity in a period of time is called as average velocity. Okay students, now I am going to solve some questions of page number 102. Page number 102, the questions of page number 102. Students, the first question is distinguish between speed and velocity. Students, you have already learned what is the difference between speed and velocity. Speed is nothing but an object travels in a unit time. Velocity is nothing but the object travels in a particular speed with a particular direction is called as velocity. So the only difference is speed is only the magnitude. Only the magnitude is nothing but numerical value, but velocity is magnitude plus direction. So only the magnitude, that's why it is a scalar quantity, but velocity is vector quantity because here the magnitude plus direction. This is what the difference between speed and velocity. Second question, under what conditions is the magnitude of average velocity of an object equal to its average speed? You can observe this one. Average velocity is equal to average speed. When and what conditions average speed is equal to average velocity? Yes, the only condition is means when an object travels in a straight line path. You can consider here point A, an object travels from point A and reaches B. So there is no obstacles. Absolutely it is a straight line path. There is no obstacles. So in straight line path, the average velocity is equal to the average speed. So when object travels in a straight line path, when the average velocity is equal to average speed. Okay students, now going to the third question. What is the odometer of an automobile measures? So you are already seen in your automobile, any automobile, car, bike and etc. So odometer device is there that measures the distance traveled. You can see some symbols are there here like this. So this is what 3,585 kilometer like that. So this is what odometer, it measures the total distance traveled by the vehicle. So now going to the next question, fourth question. What is that fourth question? What does the path of an object look like when it is in uniform motion? So we can say which type of path we can see when the object is in uniform motion. So you already know that what is uniform motion. An object travels equal distance in equal interval of time, then it is called as uniform motion. Students, you know that in previously a straight line path shows uniform motion. In the same way, the second example, in circular path also we can see the uniform motion because there is no change in the speed. So that's what a circular path is also a uniform motion. And one more example, zigzag path is also a uniform motion. Now coming to the fifth question, you can read the question now. During an experiment, a signal from a spaceship reached the ground station in 5 minutes. What was the distance of the spaceship from the ground station? The signal travels at the speed of light, that is 3 into 10 raised to 8 meter per second. I will read once again what is given in the question. So in any experiment, any signal from a spaceship, you know that spaceship, it is in somewhere, so you can consider this is what? Spaceship. So a signal comes from the ground station, so you can say this is what? Ground station, receiving station. So it takes time 5 minutes. It takes 5 minutes. What was the distance? What is the distance from spaceship to ground station when the signal moves in a 3 into 10 raised to 8 meters per second? So the speed is given. That is what? The speed of the light is given. So we can find the distance. Find the distance. So it is very simple. Students, you already know that the formula of speed. Speed is nothing but distance travelled by time taken. So now we can observe this one. The time is given, that is 5 minutes. Minute can be converted into second because the SI unit of time is second. That's why 1 minute is 60 seconds. Multiply by 60, we get 300 seconds. And also the speed is given, that is the speed of the light is 3 into 10 raised to 8 meter per second. This is what? The given terms. What we can find? We can find the distance. So by using this formula, we can you can alter the what I want distance. So distance is equal to speed into time. So you can see this one, distance is equal to speed into time. The speed is given 3 into 10 raised to 8 and time is given 300 seconds. Multiply these two, 900 into 10 raised to 8. So you can observe this one here, the 0 is there. So you can take this into 10 raised to 8 meter, 10 raised to 10 meter. So that is what? 9 into 10 raised to 10 meter. This is what? The distance travelled from spaceship to ground station. It takes how much distance? 9 into 10 raised to 10 meter. Okay students, I hope all of you can understand the concepts of speed and velocity and also the questions. Thank you.